Welcome to part 3 of probabilities. We are looking at rules under probabilities. So this is part 3 of probabilities. So if you are new here, kindly consider, and I've given the links of the previous video I've covered in the description section of this video. You can check and watch from that end so that you can build understanding from there up to this point. So thank you once again for joining us. So let's get into it real quick. So we are continuing with our rules of probability, and we are with rule number 4. It is mutually exclusive events. We are saying that two events, let's say event A and event what, let's say B, are mutually exclusive if the occurrence of A excludes the occurrence of what, B, or if the occurrence of B excludes the occurrence of what, A. That's what we mean by what, mutually exclusive event. So the occurrence of A means that once A occurs, B cannot occur. Once B occurs, A cannot occur. So both of the events cannot occur at the same time. That's what I mean by what, the mutually exclusive event. And since both cannot occur at the same time, we can say that, remember, in our previous video, we said both means what, intersection, and we are using it here. That two events, since two events cannot occur at the same time, then we are saying that the probability that two events, let's say A and B, will not occur at the same time because they are both, and means what, intersection, will not occur at the same time is equal to what, 0. That is a rule. That is the assumption. Because they cannot occur at the same time, then their probability is what, 0. Because I hope that is clear. That's what I mean by what, a mutually exclusive event. So meaning that since both of them cannot occur at the same time, it is something that one will occur or the other will occur. It is certain that A will occur and B won't occur, or B will occur and A won't occur. So we can write it in a probability form by saying that if two events are mutually exclusive, then we can say that first, if they are mutually exclusive, means that if A occurs, to exclude B occurrence. If B occurs, to exclude A occurrence. So in that we can say that the probability of A and B occurring wouldn't occur. So it makes it what, 0. That's why we have indicated the intersection B is 0. So since it's mutually exclusive, if A is occurring, then B won't occur. So we can say the probability of A or the probability of what, B. The event, all of them has equal chance of occurring, but just that both of them cannot occur at the same time. So we can say that it is probability of what, A occurring where B cannot occur, or B occurring where A cannot occur. And we learned that if you have or in any, once you hear of or in any probability statement, we mean what, addition. So here I can write this as or we mean addition, or we mean what, the union. So we can say that I can write in this form, A, probability of A or what, B. I can say that it's the same thing as probability of what, A union what, B. And since we are saying the probability of what, the two events cannot occur at the same time, it is 0. Even if you want to apply the either or situation, which says that the probability of what, A union B would have been probability of A plus probability of what, B, minus probability of what, A intersection B. Here B is 0, so even as I have to be 0 here, it's the same thing, that it won't change. So it becomes what, probability of what, A plus probability of what, B, minus 0. What is minus 0? It still remains the same. So that's why anytime you are in mutually exclusive event, and since the two events cannot occur at the same time, we straight away say that the probability of A union B, or the probability of one occurring, the probability of A occurring where B cannot occur, or the probability of B occurring where it cannot occur, can rewrite as probability of A or probability of what, B, which is a union, will be the same thing as probability of A plus probability of what, B. So there's no need to bring this because after all it's 0. So no need to bring. So we can therefore conclude that the probability of A union B, or the probability of A or probability of B occurring is probability of A plus probability of what? B. Please take note of that. And anytime these conditions is applied, you'll be heard or you'll be given an indication where the two events are mutually what? Exclusive. That is only when you can chip in this concept of mutually exclusive event, where you have probability of the two events. So if let's say what would be three events A, B, C, it would have been probability of what? A, right? Probability of what? B. So meaning that the two events cannot occur at the same time. So it became probability of A plus probability of B plus probability of what? C. And that would have been all. Because none of the events can occur at the same time. So that is the concept of mutual exclusive. I'm saying that before you can use this in a question, they will give you a hint that this is a mutually exclusive event, and then you go by the bed. If you are not told that this is a mutually exclusive event, then the normal rule apply, the either or situation, rule number 3, where you're going to apply this, then you actually fit in the probability of A union. But here, since it's 0, that is why there's no need for you to bring it. Then you just write here straight away like that. So let's take note of that. So that is that in that case. That is that in that case for mutually exclusive events. So let's take note of, so we can take an example in that case. So it is an illustrative question on rule number 4, mutually exclusive. Let's see whether it actually denotes that. In a tournament, the probability of team A winning the cup is what? 1/3. That of team B is 1/4. And that of team C is 1/5. What is the probability that A, team A or team B wins the cup? B, neither team A or neither team A nor team C wins the cup. So let's see, when it comes to the contest of football and in winning, we realize we made it clear that when it comes to anything of wins, it is certainly that two events can win a particular event, or two activity can get always the same as getting the same outcome. It's certainly not possible. So it is either one team wins and another team lose. So since actually in tournament or in football, no two teams can win at the same time, then it makes the two teams mutually what? Exclusive. So one will win and one will what? Lose. Means that one wins, it excludes the other in winning, and the other will lose. So that is the whole idea. So once this has been established, then we can say that this requirement is, or this question is a question of what? Mutually exclusive event, since two teams cannot win at the same time. That makes it a mutually exclusive event. So it's actually a mutual exclusive what? Event. So let's take note of that. I hope that is clear, because two teams cannot win at the same time. One need to win, another need to what? Lose. And that is true. So the reason why we had team A or team B wins a cup, because it is certain that either team A wins and team B lose, or team B wins and team A would lose. So it makes it what? A mutually exclusive event. And we say a mutually exclusive, since two teams cannot win at the same time, it makes their probability what? 0, and there's no need for you to bring the 0. Just straight away move by saying probability of team A plus probability of team what? B, then add, then get their result. So therefore I can say that if I have my solution down here, I can move along to conclude. So we know that the probability of team A in the question was 1/3, and the probability of team B was 1/4, and the probability of team C is 1/5. So if I'm going by the first requirement, then probability of team A or team B wins the cup will be probability of A or what? B, which is the same as probability of A union B, and which is equal to what? Probability of A plus probability of what? B. And you're saying that since they are mutually exclusive and no two teams can win at the same time, makes their intersection what? 0. So no need for you to win. So therefore, we can say that probability of what? A union B is equal to probability of A, which is what? 1/3 plus the probability of what? B, which is what? 1/4. So when we add, let's see the outcome. When I add the two, I had what? 7 out of 12. Well, there's same with 12. So 3 goes to 12, how many times? 4. Multiply by 1, 4. 4 goes to how many times? 3. Multiply by 1, make it 3. So you add, you get it. So it was what? 7 out of what? 12. What about B? So the B is also saying that neither team A nor team C what wins the car. So the same thing that is true for the two teams that cannot win at the same time is also true for two teams we cannot what? Lose at the same time. So two teams cannot lose at the same time. Neither two teams can win at the same time. So since two teams cannot lose at the same time, the intersection of their losses will be 0. So in that, you are still going to apply your mutually exclusive event because two teams cannot lose at the same time. It's either one lose and one wins. Alright, so either team A lose and team C wins. But here he said that neither of the two actually wins the cup. And once neither of the two actually win the cup doesn't mean that the two teams will also lose at the same time. At least when we are arranging them in positions, there will be one person or the one team that will lose actually. Okay, so in that we are going to find what? The mutual exclusive event between their losses, in which in other case is going to be the probability of if they win, then we subtract from what? 1. So you are going to apply the complementary rule that we did. So here it becomes 1, the probability becomes what? 1 minus the probability. So here, probability of what? Team A union what? C. And that will give me what? The probability that neither of the two teams wins. Actually, neither of the two teams what? Wins. So that will give me A intersection what? C. A bar intersection C bar. That is neither of them wins. The two of them doesn't win. Okay, so if they don't win, then means that we take into account the probability that they should have won if the two of them win. And since they are mutually exclusive and two of them cannot win at the same time, it becomes what? Or, and you're going to add. Okay, so here it becomes 1. It becomes 1 minus, what is the probability of A winning, which is what? 1/3 plus the probability of C winning, which is what? 1/5. Okay, and that will give us a probability of A not winning, likewise C not winning. So the end result, let me bring the end result here. So you take a calculator, you punch, and let's see the outcome. So when I add 1/3 plus 1/5, I'll be getting what? 8/15. Then I'll subtract 8/15 from the 1, and I'll be getting what? 7 out of what? 15. So actually, there is a probability that the two teams, neither team A nor team B what? Wins. So this is actually it's actually the probability that if they would have won, and since they are mutually exclusive, both cannot win at the same time, it becomes all rule where you're going to what? An addition. That's why we added 1/3 and 1/5. subtracted from 1, then we had this in that case. So let's take note of that. That is 7 out of 15, this one. So that is rule number 4. Let's move on to rule number 5. So rule number 5, exhaustive event. So we are saying that two events are exhaustive. For example, if I have x and y, we are saying that x and y are exhaustive if probability of x union y is equal to what? The sample space. And in that is going to be what? The probability of x union y is going to be what? 1. Call the sample space the total what? Outcome, right? Set of possible outcomes. So if you find a probability of set of possible outcome is what? 1. So that's what we mean by an exhaustive event. Two events are exhaustive if the probability of the two events in terms of union is equal to what? 1. That's what I mean by what? Exhaustive event. Then is equal to the sample space in that case. Probability of sample space in that case. So for example, if I have the same x and y, if I have the same what? X and y as two events, okay, and I'm asked to show the relationship, show whether x and y are mutually exhaustive and at the same time mutually exclusive. How are you going to go by that? You are asked to show that x and y are mutually exhaustive and at the same time mutually what? Exclusive. How would you go by that approach? So if I have this, in that case, I want to find the relationship. This is how I'll go. We know that if two events are exhaustive, then we can say that the probability of what? X union y is equal to what? X. That's sample space, and is equal to what? 1. And per the union approach, then we can say that if that is so, then we can say that probability of what? X plus probability of y will give me what? 1. So that is the exhaustive approach. The exhaustive. Alright? And then if it is mutually exclusive, we are also saying that if it's mutually exclusive, then the occurrence of one event will exclude the occurrence of the other. So in that, no two events can happen at the same time. So that one too, we said the probability of what? The probability of such event, let's say x union what? Y will also be equal to what? Probability of x plus probability of what? Y. That is exclusive event. Okay, so once you get this information, that you can clearly see that, therefore we can say that we have x union y is the same thing as this 1. So we can conclude that therefore 1 can be equal to, I want to take this and link with this, will be equal to probability of x plus probability of what? Y. I hope that is clear. Okay. So if that is so, I can say that if I want to find the probability of, let's say, y, I can say that it is 1 minus what? Probability of x. And that will give me probability of what? Y. Okay. Then I go on to find the probability of what we call the event which won't occur for x. I want to find the probability that s won't occur. How that one's going to be? So that one too, if I find a probability that an event would occur, s will occur, that one too going to be what? Going to be this. How should I put it? Probability of x, that's an event will occur, also going to be what? 1 minus the probability that s will occur, which is going to be this. I'm driving some equations, so take note. So you see we have equation 1, you have equation what? 2. So what is the relation that you are seeing here? in terms of exhaustive and exclusive. First, I said I wanted to find a probability of what? The Y events occurring. And based on this equation, I subtracted what? P of S from 1. Based on this equation, I subtracted what? PS from 1, and I had this equation 1. Then I went along to say that I want to find the probability that S won't occur. And if that is true, then that one's your probability will be 1 minus probability that S will occur, and this is what I'm having. And what are you seeing between equation 1 and equation 2? You can clearly see that equation 1 and 2 are similar, right? So we can say that equation 1 is equal to what? Equation 2. So therefore we can conclude that P of X bar is equal to P of what? Y, isn't it? Yes. Which in turn we can say that therefore X bar is equal to what? Y. The event that S won't occur is equal to what? Y. So in that we can talk about the exhaustive and exclusive. Or if you want to even go along to make it so easy to clarify, sorry, I should have shown it to you. To make it easy so to clarify, we can even use what we call application side of it, tossing of a coin. Remember, when you toss a coin, in mutually exclusive, it is not possible that a head and a tail can happen at the same time. It's never, that event won't happen. So since the head or a tail, when we toss a coin, when you have a coin, since a head or a tail cannot happen at the same time, then we can say that tossing of coin will result in an exclusive event, because either when you toss a coin, either you get a head or what? A tail. Okay, so it can be a mutually exclusive what? Event, because you can't get what? Two head and tail happen at the same time or occurring at the same time. So it becomes what? Mutually exclusive. And it becomes mutually exhaustive, where if the head occurs, the complement of what? The head not occurring together with the head occur will give me what? 1. Or better still, since if a head occurs, means that the tail won't occur. And if tail occur, means that head won't occur. So it means that each of the events have what? Equal chance of being what? Occurring. So once they have an equal chance of being occurring, then we can say that there is a probability of what? Either a head or probability of what? Either a tail. And that will give me what? 1 as mutually what? Exhaustive event. This. And that will be what? A union. So you can use tossing of coin as a practical application. Practical application for mutually exclusive event and mutually exhaustive event. Tossing of coin is one example of it. So let's take note of that. So this is where we bring an end to part 3 of rules of probabilities. So in our next video, we're going to continue with the rules and conclude finally on that. So I'll see you next video where we talk about the final part of probability. So if this was helpful to you, please consider subscribe, like, and share. I'll see you. Bye bye.